Good morning to all of you students. In this video, we are going to discuss some important questions are there. Okay. So number one, we are going to discuss the reactivity of aldehydes and the ketones. What is it? Reactivity of aldehyde and ketones. First of all, they told that both are undergoing the nucleophilic reaction, but what they told there, ketones are less reactive. Ketones are less reactive than the aldehyde. What they told, ketones are less reactive than that of aldehyde. Why? So that only we are going to do there one by one. Okay student, you see please all of you what to do there in this case. There are number one, first factor is there inductive effect. Okay, then number two factor is there steric effect. Number two is there steric effect. Number one is inductive effect, number two is steric effect. So whenever we are talking about the inductive effect, okay, you see all of you please, let it be, I am discussing now number one, inductive effect, CH3COH, and this is CH3COCH3. Then what to do there in this case? This is plus I effect, but here in this case plus I, and here is also a plus I. Okay, both sides there is a plus I effect. Oh, is that clear? Now we know very well this is the electron releasing group. The electron, they will release the electron, then on the carbon electron density is going to be increased, but here in this case there is more electron density, there is less electron density. So where the positive charge will be more, but in this carbon positive charge will be more, in this carbon positive charge or electrophilicity will be less. So nucleophile can attack very easily, nucleophile can attack more easily in the case of aldehyde. Clear? That is why nucleophile can attack more easily in a case of aldehyde as compared to the ketones. So regarding this only, they are giving you sometime one question also, that if we are comparing HCOH and CH3COH. Okay, now last one is there CH3COCH3. Then tell ki which is most reactive. Now you can tell which one will be most reactive. Obviously number one is this one. Why this one is most reactive? Because there is no alkyl group. So positive charge on the carbon will be maximum, electrophilicity of the carbon will be maximum. Is that clear to you to all? Okay. Now after that, but we are going to discuss the second factor. Second factor is here, that is known as a steric factor. What is it? Steric factor. Steric means rush. Okay student, now what they told, the size of the alkyl group is larger than the aldehyde, as we know very well, and in the aldehyde there is only one alkyl group, but in the ketone there are two alkyl group. So where the steric hindrance will be more? Steric hindrance will be more in the ketones. You just see all of you, I am writing it with the example. This is the formaldehyde. Now see, this is aldehyde. You see please, but it's the same only, that's just we are explaining with the different factors. Now you know very well which is more reactive. This one the reason we have given the plus I effect. Here we can say here is least steric hindrance, least rush is very less. Here is one alkyl group, here is two alkyl group, so rush is maximum. तो means as the steric hindrance is increased around the carbon, steric hindrance is going to be increased around the carbon, then attack of nucleophile will become difficult. Attack of nucleophile will become difficult. Is that clear to you to all? Okay students, so we have done with the two factor. Number one is inductive effect, number two is their steric factor. Okay students, then after that we are going to do next topic is there, we have to compare for the aromatic aldehydes and the ketones. What we are going to discuss about the aromatic aldehydes and the ketones. So whenever we are talking about the aromatic aldehyde and the ketones, what we are saying, usually aromatic aldehydes and ketones are less reactive than the aliphatic. The reason behind it, I will tell you. Okay, you see all of you. We can discuss within one example, that is, we can do it with one example, that benzaldehyde, let it be, what is it? Benzaldehyde is less reactive than that of the aliphatic aldehyde, means RCHO. Why? This is due to the resonating structures. Okay, you see please, all of you, when I am going to draw the resonating structure for the benzaldehyde, what is going to come over there? This is a benzaldehyde, CHO. Okay, and now we know very well around the oxygen, this group is here. Now this pair will go there, then what is going to happening over there? There will be double bond, then H, then O negative, like this way it is. Then there will be a positive charge. There will be a positive charge. Is that clear? Now after that, what to do there? Double bond C, then O negative, and then H. Then again there will be a positive charge. Is that clear? Same way we can draw one more structure. Okay, then double bond, then COH is there already. Okay, then there will be the positive charge. Now student, you see there, all of you, in the benzaldehyde there is a positive charge at the ortho and the para position. What is it? Ortho and the para position means here ring is acting as an ring is showing plus I effect. What is it? Plus I effect. So means the magnitude of positive charge on the carbonyl group is decreases. But when the electron is going this side, all of you see there, when the electron is going this side, it means on this carbonyl carbon, positive charge is going to be decreased. When the positive charge is going to be decreased, it means nucleophilic attack will become difficult. Okay, nucleophilic attack once again, because the ring is showing here plus I effect. So electron is moving towards the carbon. So on the carbon, positive charge is going to be decreased. Okay, positive charge is going to be decreased. Therefore, nucleophile can attack becomes difficult. Okay, therefore, aromatic aldehydes and ketones are less reactive than the aliphatic aldehydes and ketones. Okay, so after that, beta, whenever we are comparing the aromatic aldehyde and ketones, what we have find out that aromatic aldehydes are more reactive than the alkyl aryl ketones. You see please, all of you, suppose I am writing C6H5CHO, here I am writing C6H5COCH3, here I am writing C6H5 CO C6H5. So beta one thing is clear, which one is the aldehyde from them? Please tell me which one is the aldehyde. This is the aldehyde, most reactive. Now from these two, which one will be the most reactive? Obviously this one. Why? Because this is containing CH3, but here both are the aromatic compound is there. Clear? So that is why benzaldehyde here will be the most reactive. Okay students, so this was the explanation of the reactivity of aldehydes and the ketones. Thank you very much to all of you.